Hi, good morning, everyone. In today's session, we'll see another program, that is, write a program to check whether given number is prime or not using function. First, we'll see what is a prime number. A prime number is a natural number greater than 1 that has no positive divisor other than 1 and itself. That is, the prime number is a number that has no positive divisor other than 1 and itself. Say for example, I've taken here few natural numbers. It is 2, 3, 5, 7, 11. We take 2, the divisor of 2 is 1 and 2. That is 1 and itself. Hence it is a prime. If I take 3, divisor of 3 is 1 and 3. Hence it is a prime. And similarly, if I take 11, the divisors of 11 is 1 and 11. That is 1 and itself. Hence it is a prime. So let me generalize this procedure. So I have listed out few numbers here with the prime and not prime numbers. So for each number, I have again listed out the devices for that number. So let me take 10. The devices are 1, 2, 5, 10. And if I take 11, the devices are 1 and 11. And similarly, if I take number 12, the devices are 1, 2, 3, 4, 6, 12. So the idea for that prime number is, so we have to check that for the given number. So if the divisor is 1 and itself, then it is a prime. If it is more than 2, then it is not a prime. Okay. So let me see here. If I take number 10, so 1 is a anyway the divisor for prime and non-prime number. Hence will start from the in 2. So the initial value will start with the 2. From 2 to n will check. So in this case, the initial value will check from the 2 and up to n value. That is, in this case, it is 10. We'll check each number. And then if you observe here, the n value is 10. The previous value is 5. That is n by 2. It is 5. 10 by 2 is 5. And similarly, so that is another not prime number. It is 12. And we'll start with the initial value 2. Start checking the divisor from 2 to n value. Okay. So the n is in this case 12. This is the previous divisor. Previous divisor is 6. And if you observe here from 6 to 12, that is from n by 2 to n, there will be no divisor. There will be no divisor from 6 to 12. That is from n by 2 to n. Let me see another example. Let me take or. So here the divisor of 16 is 1, 2, 4, 8, 16. Let's start with the from 2. From 2 to 16, we have to check for all the numbers whether it divides the n value. And if you observe here, the n value is 16 and the previous value is 8. That is n by 2 is 8. From 8 to 16, that is from n by 2 to n, there will be no divisor. Hence, we restrict our search only from I is equal to 2 to n by 2. I is equal to 2 to n by 2 in general. And if you find any number between 2 to n by 2 which divides n, then that particular number is not a prime number. Okay. And if you did not find any number from 2 to n by 2, then it is a prime. We return a true. So this is the idea of how to find a prime number. Okay. Let me see the program for the prime number using a function. Since we are using a function, so we have taken the main function here and the user defined function here. Okay. The first will declare the number n of type integer and will prompt the user to enter the number. Whenever the user sees this message, he will input the number and that number will be read into this particular address of num in the memory. And this actual value from the user will be passed as a input to this function. And whenever a controller reaches this function, it automatically moves to the exact definition of that function. And in the function definition, so this is the function header and this is the function body. So in a function, so whenever the function is referenced, we have to declare the function prototype or function declaration. So before referring any function, we have to declare that function. And the function declaration, it is similar to function header except the semicolon. Hence we have taken void, prime, int, and the parameters are optional. Hence we put a semicolon. Okay. So whenever the controller reaches this function call, it automatically moves to the exact definition of that function. And here this is a function header and we have a function body and this logic involves for the prime. Okay. And this is we are not returning anything to the function, as we have taken void and the function name is a prime and int n. So here it is a formal declaration of the variable and it is similar to that the actual parameter. To receive that value of the actual parameter, the formal parameter should have a same type. So hence we have taken int n. Okay, and this will serve as a input to this prime function. Okay. And we have taken one control variable I of type integer to iterate through the devices. And then we have taken another flag variable is equal to, initially it will be true. Okay. And this is the declaration of the control variables. Next, we have to check for the prime number. So we have to list out the devices, right? If the devices from 2 to n by 2, that is initial value, we start with the for loop 2 to n by 2, means we iterate from 2 to n by 2, and we have to check for the divisor. So to check for the divisor, we have taken that n mod I, means when you divide n by I, if the remainder is 0, then the particular number is divisible. If the number is divisible from 2 to n by 2, then put up the flag and come out from the for loop and check that one. That is, if flag remains 1, means it is a prime. If the flag returns to false, then printf, it is a not prime. So this is the complete program to check for a given number is prime or not using a function. Let me trace this particular function, and if you have any doubts, it will be clear. So here I have taken the logic for that prime number. Okay. So first, let me say the user have inputted the number 11, and that 11 will be copied to the formal parameter n. Okay. And so the declaration of the variables taken place. Now the initial value of I is 2. In the first iteration, I is equal to 2. 2 less than or equal to n by 2. So in this case, the n value will be input by the user is 11. 11 by 2. 11 by 2 is 5.5. Let me take approximation of that value as 5. 2 less than or equal to 5. Yes, 2 less than or equal to 5. If the condition is true, the control will come inside the for loop body. Okay. So in the for loop, we have to check for whether the given number, that is 11, it is divisible by the I value. Okay. The n value is, in this case, is 11. 11 mod I is 2. That is, if 11 mod 2 means 11, it is when you divide 11 by 2, what is the remainder you will get? Will get the remainder as 1. 1 equal to 0. Condition is false. If the condition is false, means then the control will go back to the for loop, and this updation section will receive the control. Now I will be incremented by 1. So previously it is 2. 2 plus 1, it becomes 3. So in the second iteration, the n value remains 1 and I value is 3. Next, again, the updated value will be checked for the given condition. Now the I value is 3. 3 less than or equal to n by 2. It remains same. That is 11 divided by 2. That is previous value. That is 5.5. We'll make it as a approximation value 5. 3 less than or equal to 5. Condition is true. If the condition is true, means come inside the loop for loop body and check for whether that 3 divides 11. That is, if 11 mod 3, it is next value we are checking. So when you divide 11 by 3, what is the remainder you will get? Remainder is 2. 2 equal to 0. Condition is false. If the condition is false, means the control will go back to the for loop. The updation section will receive the control. The I value is 3. Now I will be incremented by 1. Now I is equal to 4. Again, the updated value will be checked for the given condition. Now I is 4. 4 less than or equal to 5. Yes, condition is true. If the condition is true, come inside the for loop body. Again, it will check for the next value. Now n is 11 and I value is 5. When you divide 11 by 4, what is the remainder you will get? Remainder is 3. 3 equal to 0. No, it is not 0 means it is not a divisor. Hence, again the control will go back to the for loop. This updation of section of the for loop will receive the control I is equal to 4. Now I is again incremented by 1. Now I is equal to 4 plus 1, it becomes 5. The updated value will be again checked for the given condition. Now the I value is 5, 5 less than or equal to 5. So in the fourth iteration, it will be checked for 5 less than or equal to 5. Yes, condition is true. If the condition is true, means inside the for loop body, the n value is now is 11, 11 mod 5. So when you divide 11 by 5, the remainder is 1. So 1 equal to 0 means it is condition is false. 5 is not a divisor of 11. Again, the control will go back to the for loop body. The updation part, again it will be incremented. So I is equal to 5. Now I plus 5 plus 1 becomes 6. 6 less than or equal to 5. So now 6 less than or equal to 5. Condition is false. If the condition is false means the control will skip this block and it will come for the next immediate line after the for loop body. Next, it will check. So if flag is equal to 1. So in this case, it will not execute these two lines. Hence, flag remains 1 only. If flag is equal to 1, printf, it is a prime. Hence, at 11 is a particularly the input by the user, that is 11, it is a prime number and it will complete the execution. So this is for whenever a user inputs the number 11. Let me see for the non-prime number. Okay, let me say the user have input the number 10 and the 10 will be used as an input for this function, and then declaration takes place. Next, I is equal to 2. So I value is 2. 2 less than or equal to the input value by the user is 10. 10 divided by 2. When you divide 10 by 2, we'll get it as 5. Right? So 2 less than or equal to 5. Yes, condition is true. 2 less than or equal to 5. Condition is true. Come inside the loop. So now in the for loop body, we are checking that whether it is the 2 is divisor of the n value. N value is 10. 10 mod 2. When you divide 2 by 10, what is the remainder you are getting? 0. So if the remainder is 0 means then the number is divisible. So the condition is true. If the condition is true means then it will enter into the if block. So in the if block, we'll set up the flag. Flag is equal to 0. And in the next statement, we are writing break statement. So whenever a controller reaches the break, it will come out of the for loop body and it will check for the given condition. Now the flag has been set to 0. The flag is 0. It will check for this condition. 0 equal to 1. No, condition is false. Hence it will not execute this if block. And then it will come for this else. The else, the printf not a prime. So the input number is 10. It is not a prime. Okay, let me execute this program. So in the online compiler, so whatever the program I've written, so I will copy here. So I'm using online compiler here, online compiler for C with the GDB compiler. Okay. So the logic, that is user defined function, it will be written here. So again, what I have explained, same thing I will be copying here. Okay. So since here the online compiler, it will not recognize this double code. So just I will change this the double quotes. Okay. So scanf. So double quotes it will not recognize. Hence I'm changing here. Okay. And then here also in the line number 29. Okay. Then in the line number 25. So double quotes not recognized compiler. Okay. So we have done with the complete program for the prime number. So I will run this program. Now it will prompt the user enter the number. If I enter 13, if I enter 13, so 13 will be passed to this function. And it is passed to this function, it will be copied to this num formal parameters and perform this logic. Perform this logic. And after this, if I put enter, so it will be printing. So that is 13 is a prime number. 13 is a prime number. Once again, I will run this program for the non-prime number. So enter the number. In this case, I will enter 10. So whenever you enter 10, so that will be copied here from the terminal to the particular function and perform this logic. And when you put enter, so 10 is not a prime number. So this is the complete program logic and execution for the prime number. Hope you understood this one and thank you for watching.